September 2025. Amateur astronomers around the world pointed their telescopes at 3I Atlas. What they saw stopped them cold, not a faint streak, not a distant blur, a massive glowing green sphere, bigger than anything they'd ever photographed, bigger than anything in the Comet catalogs. One observer in Chile wrote on the forum, "I thought my optics were broken. Nothing should look this big at that distance." Another in Japan, "It's not a comet anymore. I don't know what to call it." By the time the measurements were compiled and cross-checked, the number was undeniable, 700,000 kilometers, half the diameter of Jupiter, and the official response? Silence. NASA's Jet Propulsion Laboratory updated the orbital elements but didn't comment on the size. The European Space Agency's Near-Earth Object Office mentioned active outgassing without addressing the scale. Because if they acknowledge how big it is, they have to explain how it got that big. And right now, they can't. Because every model, every equation, every precedent says this is impossible. Let's start with context. Numbers this large become abstract quickly, so we need comparisons that make the scale visceral. Jupiter. The baseline Jupiter is 139,120 kilometers in diameter, the largest planet in our solar system. A gas giant so massive it could swallow 1/300 Earths. Its Great Red Spot alone, a storm that's been raging for centuries, is wider than our entire planet. When you look at Jupiter through a telescope, you're seeing something genuinely enormous. A world so large it dominates the outer solar system, holding dozens of moons in its gravitational grip. Atlas's Coma is half that size, 700,000 kilometers, not the solid body, not a planet, a cloud. A diffuse envelope of gas and dust surrounding a nucleus estimated to be somewhere between 0.3 and 5.6 kilometers across. That's the size disparity we're dealing with. A solid core the size of a small mountain, wrapped in a glowing sphere that could fit Jupiter inside it with room to spare. The Sun-Venus distance. Another way to grasp this. The average distance between the Sun and Venus is about 108 million kilometers. If you placed 3I Atlas's Coma between them, it would stretch more than 0.6% of that distance. Doesn't sound like much. Consider this. Light, traveling at 300,000 kilometers per second, takes 2.3 seconds to cross 700,000 kilometers. That's the distance light covers while you read this sentence out loud. Earth comparisons. Earth's diameter is 12,142 kilometers. You could line up 55 Earths side by side and still not span the width of 3I Atlas's Coma. If 3I Atlas were centered on Earth, its outer edge would extend well past the Moon's orbit. The Moon sits at 384,400 kilometers away. 3I Atlas's Coma would swallow it entirely and continue outward for another 300,000 kilometers in every direction. This isn't a comet. It's a cosmic leviathan. The timeline. 8 weeks here is what makes this truly disturbing. The growth rate. In July 2025, 3I Atlas was catalogued with a modest coma, perhaps a few tens of thousands of kilometers across. Visible only to professional instruments. Faint, unremarkable compared to other interstellar visitors like Oumuamua or Borisov. By early September, amateur networks began reporting anomalies. Brightness increases. Unusual size measurements that didn't match predictions. By late September, the cross-continental verification was complete. The Coma had exploded to 700,000 kilometers. That's 8 weeks, 2 months, 60 days. Jupiter took tens of millions of years to accumulate its mass through gravitational collapse, pulling in gas and dust from the primordial solar nebula. 3I Atlas achieved half that diameter in less than the time it takes a human pregnancy to reach full term. Something is pumping material into space at a rate astronomy has never documented. The size alone would be enough to make 3I Atlas extraordinary. But it's the color that turns extraordinary into inexplicable. Why green? When most people think of comets, they picture a pale, whitish glow, maybe a hint of blue in the ion tail. That's what sunlight reflecting off dust and ice looks like. Some comets do appear greenish, and for decades, astronomers knew why. Diatomic carbon, C2.C2 molecules form when sunlight breaks apart larger carbon compounds in the comet's coma. When these molecules absorb ultraviolet light and re-emit it, they produce a characteristic green glow in what's called the swan bands. named after the Scottish physicist William Swan, who first observed them in the 19th century. This process is well understood, predictable, common. But 3I Atlas's green glow doesn't come from C2, the missing carbon spectroscopic. Teams at the European Southern Observatory and the Gemini South Observatory pointed their instruments at 3E Atlas expecting to see the swan bands. They're the smoking gun for green comets. They found nothing. No C2 emission. No diatomic carbon signature at all. Dr. Lina Sato, leading the spectroscopy effort with the James Webb Space Telescope, described the results as baffling. In a leaked internal report, she wrote, "We've checked the calibration 3 times. The green light is there. The source should be obvious. But the expected emission lines are absent. So if not C2, then what? Atomic oxygen. The forbidden line. The answer lies in a phenomenon that sounds almost mystical. Forbidden transitions. In quantum mechanics, certain atomic transitions are labeled forbidden, not because they can't happen, but because they're extremely unlikely under normal conditions. They require specific, rare circumstances, low-density environments, particular energy states, precise timing. One such transition occurs in atomic oxygen. When oxygen atoms are excited by ultraviolet light or energetic electrons, they can emit a specific wavelength. 5577 angstroms. That's a vivid green. This is the same emission that causes Earth's auroras to glow green when solar wind particles excite oxygen atoms in the upper atmosphere. E Atlas is glowing green for the same reason, but not because of water vapor, the usual source of oxygen in comets. Because of carbon dioxide, the CO2 dominant standard comets are water-rich. H2O dominates their composition. When sunlight heats the nucleus, water ice sublimates, releasing oxygen that can produce weak green emissions. But water is rarely the dominant source of green glow. C2 usually takes that role. Atlas flips the script entirely. Spectroscopic measurements from JWST, confirmed by ground-based observatories, show a CO2 to H2O ratio of approximately 8.1. Some measurements push that as high as 20.1. That means for every molecule of water vapor, there are 8 to 20 molecules of carbon dioxide. This is not just unusual, it's alien. Literally, that CO2-rich bodies are rare in our solar system's comet population. Water ice forms abundantly in the cold outer regions where comets originate. CO2 requires even colder conditions, temperatures found in the interstellar medium, far from any star's warmth. E Atlas carries a chemical signature that points to formation in a completely different stellar environment. Colder, darker, more carbon-rich than the region where our sun and planets formed, and when that CO2 sublimates, it releases enormous quantities of atomic oxygen. That oxygen, excited by solar ultraviolet radiation and possibly by electron bombardment within the Coma, emits the forbidden green line at 5577 angstroms. The result: a massive, glowing green sphere unlike anything in the comet catalogs. The spectral anomalies, but the oddities don't end with the green glow. Johns Hopkins spectroscopists, analyzing high-resolution spectra from the VLT's UVES instrument, identified absorption lines that don't match any cataloged molecular or atomic species. Some features hint at metallic alloys, nickel, specifically, which has been detected at 4.6 grams per second outflow as of late August. But iron, nickel's usual companion in cometry chemistry, is absent, below detection thresholds. Other absorption features align tentatively with rare earth elements and exotic compounds described only in theoretical chemistry papers, materials that don't form naturally in simple, icy bodies. Dr. Carrie Liss's team at Johns Hopkins has been cautious in their public statements. But privately, the debate is intense. Are these features the result of truly alien chemistry? Ices and compounds formed under conditions we've never observed? Or are they signatures of something engineered? The data doesn't provide clear answers, but it does provide questions that refuse to go away. Now we arrive at the core problem, the one that makes astrophysicists uncomfortable, the one that institutional channels avoid discussing in detail: energy. The solar flux problem 3I Atlas, as of September 2025, sits at approximately 2 astronomical units from the Sun. That's twice the Earth-Sun distance. At that range, solar radiation is significantly weaker, about 1/4 the intensity we experience on Earth. Comets brighten and grow their comas as they approach the Sun because solar heating sublimates surface ices. The closer they get, the more intense the heating, the more gas and dust released. But there are limits. You can calculate how much energy a comet nucleus receives based on its distance from the Sun and its surface area. You can estimate how much ice that energy can sublimate. You can model the resulting coma size. Those models work. They've been validated on hundreds of comets over decades of observation. For 3I Atlas, the models fail. At 2 AU, with a nucleus estimated between 0.3 and 5.6 kilometers in diameter, solar heating should produce a coma tens of thousands of kilometers across. Perhaps, in extreme cases, 100,000 kilometers, not 700,000 kilometers. To create a coma that large requires sublimating ice at a rate far beyond what the surface area and solar flux can support. The surface area constraint. Let's do the math. Assume the nucleus is on the larger end of the estimate, 5.6 kilometers in diameter. That gives a surface area of roughly 98 square kilometers. Solar flux at 2 AU is about 340 watts per square meter. Multiply those together, and the total solar energy hitting the nucleus is approximately 33 megawatts. Now, sublimating water ice requires about 2.8 million joules per kilogram. Carbon dioxide ice, which sublimates at lower temperatures, requires about 570,000 joules per kilogram, even assuming 100% efficiency, which is physically impossible. The energy available can sublimate at most a few hundred kilograms of ice per second. But 3I Atlas is releasing gas at rates measured in excess of 129 kilograms per second for CO2 alone. Add in water vapor, dust, and other volatiles, and the total outflow climbs higher. That's within the bounds of possibility for a comet at 2 AU. Barely. But here's the critical point. That level of outgassing doesn't produce a 700,000 kilometer coma. Not even close. To maintain a coma that large, gas must be venting at rates orders of magnitude higher. And that requires energy orders of magnitude beyond what the Sun provides at that distance. The 10,000 gigawatt estimate. Earlier estimates, based on trajectory corrections and tail modulation, suggested 3I Atlas might be producing around 10 gigawatts of power, equivalent to 10 large nuclear reactors. Those estimates were conservative. They assumed the object was only modulating its jets, not creating a structure the size of a small planet. Now, with the coma measured at 700,000 kilometers, the energy requirement skyrockets. To sustain that volume of gas and dust, to overcome solar radiation pressure, to maintain the observed brightness and chemical activity, the power output must be closer to 10,000 gigawatts. 10 terawatts. For comparison, the entire electrical grid of Earth, every power plant, every generator, every source of electricity humanity operates, produces about 3,000 gigawatts on average. Atlas, if these estimates hold, is outputting more than 3 times the total power generation of human civilization, and it's doing so with a solid core the size of a mountain. Where does that energy come from? There are no good natural answers. Solar panels? At 2 AU, even with perfect efficiency, you'd need a collector array tens of thousands of square kilometers in size. The nucleus is at most a few kilometers across. Radioactive decay? Natural isotopes like uranium-238 or thorium-232 produce heat, but not at terawatt scales. You'd need refined, concentrated nuclear fuel, something that doesn't occur in nature. Chemical reactions? Combustion requires an oxidizer. In the vacuum of space, sustained chemical reactions at these power levels are implausible. Gravitational or tidal heating? 3I Atlas is not orbiting a massive body like Jupiter. There's no tidal stress to generate internal heat. That exhausts the conventional options. What's left is uncomfortable to say out loud, but the data forces the question, could there be an artificial power source inside 3I Atlas? Not natural isotopes, not solar, not chemical. Something designed, something built, something brought from another star system with the express purpose of producing energy on a scale that dwarfs anything humanity has ever achieved. Amateur witnesses versus official silence. While institutional astronomy stays cautiously vague, the amateur community has been anything but silent. The Chile observer, optical breakdown. In early September, an amateur astronomer in Chile using a 12-inch Dobsonian telescope captured an image that immediately went viral in astronomy forums. The object filled a significant portion of the frame, glowing green, diffuse, enormous. His post read, "I thought my optics were broken. I checked collimation twice, cleaned the mirrors, swapped eyepieces. It's still there. Nothing should look this big at that distance. I've been imaging comets for 15 years. This is not normal." Within hours, other observers chimed in. Japan, Turkey, Australia, Europe, all reporting the same thing. 3I Atlas was visually massive. The Japan observer, Identity Crisis, a veteran astrophotographer in Japan, known for his meticulous comet documentation, posted a more existential observation. "It's not a comet anymore. I don't know what to call it. The structure is wrong. The scale is wrong. The color is too vivid. I've logged over 200 comets in my career. This doesn't fit the pattern." His images, stacked over multiple nights, showed the coma expanding in real time. Measurements using starfield references confirmed the growth, roughly 5,000 kilometers per day. Cross-Continental Verification Bill. Gray's orbital software network became the clearinghouse for measurements. Observers uploaded their data, timestamps, telescope specs, imaging parameters, astrometric measurements. The results were consistent across platforms, across continents, across equipment types. Coma diameter, 700,000 kilometers, with error margins of less than 5%. One forum user summarized the mood. "We're watching something unprecedented unfold, and the institutions that are supposed to study this stuff are pretending it's business as usual." NASA's non-response, NASA's Jet Propulsion Laboratory, which maintains the public database of small solar system bodies. Here updated 3I Atlas's orbital elements on September 15th. The entry included perihelion distance, eccentricity, inclination, epoch. What it didn't include: Coma size brightness anomaly notes, spectroscopic data summary. Any commentary on the scale, the absence was conspicuous. For other notable comets, Hale-Bopp, McNaught, Neowise, JPL's database includes detailed observational notes, size estimates, and links to scientific papers. For 3I Atlas, the third interstellar object ever observed, exhibiting the largest coma in modern records, silence. ESA's vague statement, the European Space Agency's Near-Earth Object Coordination Center issued a brief update on September 20th. YI Atlas continues to exhibit active outgassing as it approaches perihelion. Observers are encouraged to contribute data to international monitoring efforts. Active outgassing. That's the extent of their acknowledgement. No mention of the size. No discussion of the energy problem. No attempt to explain why this active outgassing is producing a structure half the size of Jupiter. The pattern of suppression. This isn't the first time institutional channels have downplayed anomalies with 3I Atlas when the CO2 dominance was first detected. Official statements mentioned contains water ice without specifying the ratio. When the 4-hour thermal pulse was discovered, press releases called it periodic activity without addressing the rhythmic precision. When trajectory corrections were observed, NASA cited non-gravitational forces without quantifying the implied power output. Now, with the coma reaching unprecedented size, the response is the same. Vague acknowledgement, no substantive explanation, and a conspicuous avoidance of the questions that matter most. Why? One possibility: they genuinely don't know, and admitting that publicly would undermine confidence in institutional expertise. Another possibility: they do know, or strongly suspect, and the implications are too destabilizing to discuss openly. Either way, the silence speaks volumes. What could create this? The Fortress. Hypothesis. Early in 3I Atlas's observation history, a nickname emerged among amateur communities: the Fortress. It wasn't meant literally at first, just a metaphor for the object's apparent resilience, its refusal to fragment, its steady brightness, its organized behavior. But as the coma grew to 700,000 kilometers, the nickname took on new meaning. The subsurface chamber theory, one natural explanation, still within the bounds of conventional cometry science, is the subsurface reservoir model. Imagine the nucleus honeycombed with chambers, voids filled with volatile ices insulated by a thick crust. As solar heating gradually penetrates, these reservoirs rupture, releasing massive quantities of gas all at once. This could, in principle, explain sudden outbursts and large comas. The problem: sustaining a 700,000-kilometer coma requires continuous massive outgassing over weeks, not a single outburst, not periodic eruptions, constant high-volume release. For that to work naturally, the subsurface chambers would need to be enormous, occupying a significant fraction of the nucleus's volume, and they'd need to vent through an organized network of conduits. That starts to sound less like geology and more like engineering. The engineered power source hypothesis. If natural explanations fail, the alternative is design. Imagine a spacecraft, not in the traditional sense of metal hull and rocket engines, but a probe built for the interstellar medium, using ice as radiation shielding, using solar heating as a trigger for controlled outgassing, using the coma itself as camouflage. Inside, a power source, not solar panels, not chemical reactions, something far more advanced, perhaps a fusion reactor scaled to terawatt output, perhaps something we don't have terminology for yet. That power source drives the outgassing, not randomly, not passively, but in controlled directional bursts, creating thrust, adjusting trajectory, building a massive glowing shield. The fortress. This hypothesis sounds like science fiction, but it's increasingly difficult to ignore. When you have an object that produces 10,000 gigawatts of power with no identified source, maintains a 700,000-kilometer coma at a distance where solar flux is insufficient, exhibits chemical signatures, nickel-dominant, rare Earth hints, unlike natural comets, shows rhythmic, organized behavior, 4-hour pulse, trajectory corrections, carries isotopic and molecular chemistry from another star system. At what point does extraordinary comet become a less plausible explanation than artificial object? The reflectance. Anomaly. Early spectroscopic data from 3I Atlas showed something unusual, a sharp metallic reflectance signature in the nucleus. Standard comet nuclei scatter light diffusely. They're made of ice, rock, and dust, materials that don't produce strong specular reflections. Atlas's core, however, reflects light with a sharpness that suggests smooth, hard surfaces. Some spectroscopists argue this matches nickel-cobalt alloys, materials used on Earth for high-strength, corrosion-resistant applications. Could the nucleus be wrapped in a metallic shell? A hull designed to withstand the rigors of interstellar travel, cosmic radiation, micrometeorite impacts, thermal extremes. If so, the glowing green coma isn't just outgassing. It's an actively maintained envelope, a defensive layer, a shield against the hostile environment of space. The fortress. As of October 2025, 3I Atlas continues its approach toward perihelion, scheduled for late October at approximately 136 astronomical units from the Sun. And the coma is still growing. Every night, observers log new measurements. Every morning, the numbers climb. 720,000 kilometers. 740,000, some estimates, accounting for the faintest outer regions. Push past 800,000 kilometers. If this trend continues, 3I Atlas could become the largest coma ever recorded in human history. Larger than Hale-Bopp. Larger than the Great Comet of 1811. Larger than anything in the written record, and we still don't know why. What happens at perihelion? The critical moment approaches. When 3I Atlas reaches its closest point to the Sun, solar flux will increase dramatically. If the coma is already this large at 2 AU, what happens at 1.36 AU? 3 possibilities. Scenario 1. Fragmentation. The nucleus, unable to withstand the increased thermal stress, breaks apart. The coma dissipates. The mystery ends in spectacular disintegration. Scenario 2. Stabilization. The outgassing reaches equilibrium. The coma stops growing. Observations continue, but the object behaves predictably through perihelion and beyond. Scenario 3. Escalation. The coma continues expanding. Brightness increases further. The energy output climbs. And whatever is powering this spectacle reveals itself more clearly. Institutions are preparing for all three, but they're not telling us which one they consider most likely. The 2026 Dust Stream 1 certainty. 3I Atlas will leave a trail. Orbital models predict that after perihelion, the dust and gas released will form a debris stream along the object's trajectory. In mid-2026, Earth's orbit will intersect that stream. For most comets, this means a meteor shower, harmless streaks of light as dust grains burn up in our atmosphere. But if 3I Atlas is producing dust at the rates implied by its coma size, the stream could be dense. Very dense, and if the dust contains the exotic materials hinted at in the spectroscopy, metallic grains, rare earth compounds, particles designed to survive atmospheric entry, then 2026 could bring more than a light show. It could bring samples, physical evidence from another star system, raining down on Earth. Or, in darker scenarios whispered in conspiracy forums, it could bring something intentional. Microprobes, sensors, devices embedded in dust grains, scattered across our atmosphere collecting data. Science fiction? Maybe. But 6 months ago, the idea of a 700,000-kilometer green sphere appearing in our solar system also sounded like fiction. What should we do? First, keep watching. The amateur networks have proven their worth. When institutions stay silent, independent observers fill the gap. Every telescope pointed at 3I Atlas. Every data point logged, every image shared, these contributions matter. If the energy budget doesn't close, acknowledge it. If there's a genuine possibility this object is artificial, the public deserves to know. Third, prepare for paradigm shift. We've built our understanding of comets on centuries of observation. 3I Atlas is teaching us that interstellar visitors might not follow the same rules. Whether that's because their chemistry is alien, or because they're not natural objects at all, we need to be ready to rewrite the textbooks. The question that defines us. Why is 3I Atlas so big? If the answer is natural, new physics, exotic ices, subsurface reservoirs we've never encountered, then we're on the verge of revolutionary discoveries in planetary science. If the answer is artificial, engineered power sources, controlled outgassing, a designed object from another civilization, then we're on the verge of something far more profound. Either way, we're watching history unfold in real time. A glowing green giant, half the size of Jupiter, carrying chemistry from another star, producing energy that defies our models, and growing larger every single night. Subscribe to Cosmic Atlas, because when the sky grows a monster, someone needs to keep their eyes open. The fortress is here, and it's not done yet.